A roar of light. Space bends. We dive toward a hungry black hole. Time stretches like taffy. What survives the end of everything? Ready to find out? 10 quintillion years. A 1 with 19 zeros. Bigger than memory, longer than history. Can you picture it? Whole eras flash by like sparks in the dark. Jump ahead a mere billion years. Oceans hiss into steam. The sky shimmers with heat. Earth is a memory. The sun turns ruthless. Could we leave our cradle in time? Far beyond that, galaxies collide and merge. Dust lanes curl. Stars ignite and fade. Black holes prowl like apex predators. The cosmos grows strange and quiet. This is our ride to the end of time. Stay close. What we find may change how you see everything. 1 billion years from now, our home is unrecognizable. The sun, in its relentless march toward old age, has grown hotter and brighter, boiling away Earth's oceans and scorching its continents. Our planet is a desolate, barren rock, a silent monument to a once thriving civilization. But this isn't necessarily the end of the human story. Our descendants, if they've survived, would have seen this coming for millennia. They would have embarked on the greatest migration in history, scattering across the cosmos. Perhaps they found new homes on Earth-like worlds, orbiting more stable, long-lived stars. Or maybe they abandoned biology altogether. Imagine humanity transcending the flesh, becoming a civilization of pure artificial intelligence, minds uploaded into resilient machines, capable of traversing the void between galaxies. They could achieve a form of immortality, their consciousness living for eons. But even for digital gods, there is no free lunch. Immortality is not a state of being, but a constant struggle against entropy. It requires a colossal amount of energy, a resource that will become the ultimate currency in this far-flung future. Now let's leap forward another 9 billion years. The final dramatic act of our solar system plays out. The sun swells into a magnificent, terrifying red giant. Its outer layers expand relentlessly, first swallowing Mercury, then Venus, in a fiery embrace. Earth, our former home, is either consumed entirely or left as a charred, molten cinder, its fate sealed. After this spectacular death, the sun's core collapses under its own weight, shrinking into a city-sized stellar remnant, a white dwarf. It's a faint, cooling ember surrounded by the ghostly debris of its former planets. Any surviving human civilization, whether biological or digital, would have to be light years away, looking back on their ancestral home as a distant, dying memory. On this grand time scale, even the galaxies themselves are not static. The Milky Way and our colossal neighbor, Andromeda, are on an unstoppable collision course. They begin to merge, forming a new, even larger galaxy some have nicknamed Milkomeda. Stars from both galaxies are pulled into new orbits, swirling violently like cosmic dancers in a gravitational storm. Yet, despite the chaotic appearance, direct star-on-star collisions are incredibly rare. The space between stars is simply too vast. Imagine drifting through this cosmic metamorphosis. You would witness a celestial light show of unparalleled beauty, with neutron stars spinning like cosmic lighthouses and the immense silent shadows of supermassive black holes lurking at the galactic core. Occasionally, the rare collision of stellar remnants, like two neutron stars, could trigger a kilonova, forging heavy elements, and perhaps even giving birth to new stars that will shine for trillions of years, offering potential new havens for life in an aging universe. Our journey begins at the precipice of cosmic horror. Imagine a force, a phantom energy lurking in the vacuum of space, secretly pushing everything apart. This is dark energy. Right now, it's a subtle influence, but what if it grows stronger? Fast forward 22 billion years. If the most extreme theories hold true, we face a cataclysm known as the Big Rip. It wouldn't be a gentle fading, but a violent, final act. First, the cosmic web of galaxy clusters would unravel. Then, galaxies like our own Milky Way would be torn asunder, their stars flung into the expanding void. Solar systems would follow, planets ripped from their orbits. The Earth itself would disintegrate. Finally, in the last moments, the fabric of reality would shred, tearing apart every molecule, every atom, until nothing remains but fundamental particles adrift in an infinite, empty expanse. Everything we know, dissolved into chaos. But even if we escape the rip, a colder, slower fate awaits. 100 trillion years from now, the stelliferous era, the age of stars, draws to a close. The universe as we know it, a brilliant tapestry of light, will begin to fade. The last, long-lived red dwarfs will finally exhaust their fuel, sputtering out after trillions of years of slow burning. The universe's supply of hydrogen gas, the essential ingredient for stellar birth, will be depleted. No new stars will ignite. The cosmic nurseries will go silent. The last supernovas will flash and then fade, their brilliant light a final, fleeting memory of a vibrant cosmos. The universe will plunge into an unimaginable, profound darkness, a cold and silent twilight. 10 quintillion years from now, we enter the degenerate era. The universe becomes a cosmic graveyard, littered with the corpses of stars, icy white dwarfs, silent brown dwarfs, spinning neutron stars, and the all-consuming black holes. Star formation is a forgotten memory. In this desolate future, could humanity or any life persist? Perhaps as beings of pure energy, or as digital consciousness stored in resilient machines, huddled around the faint warmth of a dying dwarf star. Or maybe, just maybe, our descendants found a way to escape to a younger, brighter universe. A possibility we can only dare to imagine. Imagine humans exploring dark, cold galaxies, encountering black holes swallowing light, navigating ghostly remnants of stars, and witnessing rare cosmic events like white dwarf collisions creating new supernovae. Even more bizarre, 10 billion years from now, a 1 followed by 34 zeros, protons themselves decay, white dwarfs, brown dwarfs, neutron stars, they slowly disintegrate into subatomic dust. Reality itself begins to unravel. Finally, at Google years, 1 followed by 100 zeros, the last black hole evaporates. The universe enters the dark era, cold, silent, empty, with only a few scattered subatomic particles and dark energy stretching endlessly. The temperature approaches absolute zero. Some theorists propose the Big Crunch, where the universe might reverse and restart the cycle of existence. But scientists believe the Big Freeze is far more likely. Humanity, if it endures, must have mastered new ways of survival beyond material bodies, perhaps building universes in laboratories or transcending space and time itself. If you enjoy this video, hit like and subscribe to follow all the new what-if mysteries. Even after 15 minutes of traveling through time, the mysteries of the universe continue. Every star that dies, every black hole that swallows light, every galaxy that collides, we are witnessing the epic story of existence. Humanity's survival, intelligence, and curiosity are the only constants in a cosmos moving towards silence.